Today we're going to be graphing some functions. To begin with, what is hopefully review for you, here's the XY coordinate system. So if you're given a point like 2, 1, then plot that point. So this is telling you on the x-axis, go over by 2, and on the y-axis, go up by 1. So go over by 2 on the x-axis, and go up by 1 on the y-axis. So you go over by 2, and then up by 1. And that is 1, 2. Well, that was so easy and fun. Let's do another one. How about -3, -1? So this is the x and this is the y. So for x, -3 would be -1, -2, -3 over here. And then -1 on the y-axis is down here. So go over by -3 and then down to -1. And this point is -3, -1. And then, if asked, you could then draw a straight line through those 2 points. That's going to be the next part. So, for example, graph the line y equals 2x plus 1. Well, for a line, you only need 2 points. So basically I need 2 points like this, and then I could just connect them with my little ruler. So I could make a little table instead of writing it like this. You could write it like that, but you could also make a little table like this. And then just pick a number for x. Okay, yeah, 0, that's a good idea. So then y would equal 2 times 0 plus 1. That would be 0 plus 1, so y equals 1. And then record that information over here. And then pick another number for x. 3? Okay, sounds good. We'll use a 3. And then substitute that in for x. So that's going to be 2 times 3 plus 1. That would be 6 plus 1, so it's 7. And for a line, that is all the information you need. So on the x-axis, I need 0, and then 1, 2, 3. And for the y's, I need to go up to 7. 1, 2, 3, 4, 5, 6, 7. And then plot the 2 points. So in the x direction, sorry about that. In the x direction, go 0. And then go up to 7. Oops, I picked the wrong one. Sorry, erase that right there. Okay, here we go. 0, 1. I looked at the wrong one. 0, and then go up to 1 is this point. And then for this one, on the x-axis, go over to 3, and then go up to 7. And then get a straight edge and connect the 2 points. And there we go. If you want to be fancy, you can put an arrow on it saying the line goes forever in that direction and forever in that direction. Then, what if it's not a line? Like, what if it's quadratic functions? Quadratic functions have an x squared. They could also have some other number times x, and it could even have plus another number at the end. So, for example, number 2. How about y equals x squared minus 4x? Well, this actually makes what's called a parabola. So the shape would look like this. it could be that it's a parabola that's upside down. So it could be like this. Whenever the a is positive, it's going to look like that. If this was a negative in front, it would look like this. So this is a is positive, and this one is if a is negative. So for this, it's starting with a positive number in front because there is no negative sign right here. So it's going to look something like this. And for this, we're going to need a few points, more than just 2 points. So we'll do stuff like -1 and 0 and 1 and 2. And hopefully that's enough that I could see basically what the graph looks like. If not, I'll pick another point. So when you substitute a 1, a negative 1, that's going to be y equals -1 squared minus 4 times a -1. So this, when you square it, becomes a +1, and then a negative times a negative will be +4, so that equals 5. Then when you plug in 0, so that's going to be 0 squared minus 4 times 0, which means it's 0 minus 0 equals 0. Now substitute the 1. 1 squared minus 4 times 1. So this is 1 minus 4, that's a -3. And what about the 2? So that's going to be y equals 2 gets squared minus 4 times 2. And then that would be 4 minus 8, 4 minus 8. So that would be -4. And then let's see if that's enough information to graph it. So x is 0, 1, 2, 3, and -1. 1, 2, 3, 4, 5, -1, -2, -3, -4. Okay, so -1 and 5 is this point. 0, 0, that's the origin, that's right here. Then go to 1 and -3, and then 2 and -4. And it looks to me like I've got this much of the parabola, but I don't have the part that's going back up. So maybe I should use one more number like 3. So it's going to be 3 squared minus 4 times 3. This is going to be 9 minus 12, which is -3. So over here at 3, oops, I forgot to fill it in over here. So it's going to be at 3 and -3. So basically, previously I had up to this point, and now it's starting to come back up. And so if I then draw it so that it goes down, and then right now I'm at this lowest point. I'm at this lowest point right here. And then just make it symmetric on the other side. And it's going to go up like that. Now in the book, they expect you to use a graphing calculator. So I'm going to show you how to do it on the graphing calculator. And then if you don't have a graphing calculator, I'll take a break and I'll show you how to use Desmos for free. But on the graphing calculator, you need to go first to y equals, let me clear out that old one, and then put x is squared. And then what I do is just go to zoom standard, zoom number 6, and, okay, that's the general idea of graphing. I forgot to look at this and see it's x squared minus 4x. Oops. Minus 4x. And then go back to the graph, and you can see that that graph looks exactly like the one that I drew. Yay! We did it. Next, exponential functions. So it's very helpful to have an idea of what the graphs look like. And an exponential function looks like this. It starts off very small and it's just barely growing, and then it's going to hit the y-axis and it's going to take off and start growing very fast. That's the general idea with an exponential function. And the general formula is y equals a number times another number that gets raised to x. So for example, number 3. So like I said, you could use the graphing calculator or you could use Desmos. Once we finish these on paper, then I'll show you how to use the Desmos. And like I said, Desmos is free. Okay, so y equals, so my point with that is on the homework, if it says to use some type of their website or something like that, you don't have to, because you can use Desmos for free to do the graphing that they ask for. Or you could just do it by hand like I did right here. So then pick some values and make a little table of values with x's and y's. It's usually good to pick at least one negative, 0, and a couple of positive numbers. So when I use the negative 1, so that's going to be 2 times 3 to the negative 1. And a negative 1 exponent means this gets inverted. So the 2 stays there and the 3 gets sent to the bottom. So it's 2/3. Then when you substitute a 0, 3 to the 0 is equal to 1, which means this is 2 times 1. Then if you use an exponent of 1, well, 3 to the 1, that's just 3. So 2 times 3 equals 6. So you can see it starts off small, gets bigger, and then suddenly it's getting bigger by even more. So it's growing exponentially. And then 2 times 3 squared. So 3 squared is 9, times 2 is 18. So it grew a little bit, and then grew more, and then grew even more. So let's say that up here is 18, and I'm not going to put all the tick marks. That means right here is 9, and right about here would be 6. This is when x equals -1, 0, 1, and 2. So the first point when we use -1, that was 2/3, so that's going to be really small. And then when we used 0, that would be 2, which would be approximately right here. And then when x equals 1, it went up to 6. And when x equals 2, it goes up to 18. So the graph looks pretty much exactly like this one. So it starts off really small, and then it starts growing, and then growing, and growing faster and faster. That's the exponential. Then, cubic functions. So in general, it has x cubed. It might have also x squared. It might also have something times x. Might even have an extra number at the end. But this is what's controlling the shape of the graph. And the shape is what some people call an S-curve. It goes like this. Now, I don't know why they call that an S-curve. Does that look like an S to you? This way? No. This way? No. Flip the paper over. I don't know. Okay, anyway, enough wasting time. Then for example number 4, y equals 2x cubed plus 3. So we could just do it with paper and pen or pencil. So I'll use a negative number, I'll use 0, and a couple of positive numbers. First of all, when you substitute a negative 1, so 2 and then negative 1 is cubed plus 3. So this means negative 1 times negative 1 times negative 1. And 3 negatives in a row is negative, so that's going to be negative 1 times this. So it leaves negative 2 plus 3, 1. Then substitute 0. Well, this will just be 0 plus 3. So it's 3. And then 2 times a positive 1 plus 3. Well, that's just 2 plus 3 is 5. And then for the 2, so, oops, I forgot to write cubed. That doesn't change the answer, but I forgot to write that. And then 2 cubed plus 3. So 2 cubed is 8 times 2 is 16. So this is going to be 16 plus 3 is 19. So here's x-axis negative 1, 0, 1, and 2. And then this is going to have to be the 19. And let's see, so 5 would be down about here, and then 3 is about here. So negative 1, 1 is going to be right about there. 0, 3 will be here. 1 and 5, and then 2 and 19. So I don't know about you, but this part right here looks like I only have this part. So maybe I should have picked negative 2 also. So what if we substitute a negative 2? So that'll be 2, and then negative 2 is cubed plus 3. So this equals negative 8. And then times 2 is negative 16 plus 3 is negative 13. So negative 2 and then negative 13 is down here. And then just try to make it look like that. And then let's see what the graphing calculator says about that one. So it's 2x cubed plus 3. Y equals, clear this out, 2x is raised to the 3, move over, plus 3. Let's see, does it look like mine? Well, other than they used blue and I used red. Also, this window is going out from negative 10 to 10. And mine is just looking at that part. So if I adjust, mine goes from negative 2 to 2. So have the x's go from negative 2 to 2. Then you'll see that it now looks more like my graph. Okay, then for the very last part, so this is an example of a step function, the greatest integer function. So first of all, it has these double brackets, and what it means is you lop off the decimal. No matter what it is, you just lop it off. So in other words, what is the greatest integer that is smaller than or equal to this number? So you can think about it as whatever the decimal part is, you just throw that away. So if it was 4.01, then the answer would just be a 4. So what does the graph of that look like? So y equals the greatest integer of x. So if you pick any number between 0 and 1, and not including 1, but in between them, literally in between them, all of those numbers would start off as 0 point something. So when you lop off the decimal, it's just going to equal 0. So that means that the graph looks like this. It's just a straight line. All of them equal 0 right in here. And then this would be an open circle. Now, if you pick any number starting with 1, going up to 1.999, the decimal part will be dropped off and they would all equal 1. So then there would be a line segment that looks like this, and it would have an open circle right above the 2. Then if you pick any number between 2 and 3, so 2 point something, well, the point something is going to be dropped off. It's just going to equal 2. So anyway, it just keeps making these steps. So just like walking up steps, jump, 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 or walking down, jump, 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 jump. A step function. Okay, so now I'm going to go to my computer and I'm going to show you Desmos. So right here, I happen to have the Desmos app. So you can get the app for free and then use it, but you don't have to. You could just Google. As you can see, I was just practicing. If you just Google Desmos, D-E-S-M-O-S, and then click on this first one, then the big red button, start graphing. And there, this is not running from the app, this is running from their website, which, like I said, is 100% free. You don't need an account, you can just start using it. So the first one we did was y equals, and then on the left there's, oh, I have to put the 2, and then x plus 1. And then it makes the line for you. So graph the line. Or if you clear that one out, let me see, another one that we did was x squared. So put x, and then there's the button that says a squared, so that will make it squared, and then minus 4 times x. And then it makes the parabola. And the other good thing is you can just touch the screen if you've got an iPad, like I'm using an iPad right now, or click on it if you've got a computer, click on it with your mouse, and then you can find different points. And then clear that one out. So let me just show you, if you put y equals, and then there's this button that says capital ABC. So you can just put a letter like A. And then go back to the regular screen and then put x squared. So then in the upper left hand corner it says add slider. So I just click on that, and then when I change that A, so this is what I was talking about before. when it's a parabola, if the number in front is positive, it's going to be opening up like it is now. And then I'll slide it until it's a negative number, and now it's opening down. Up, down, up, down. It's like exercise, jumping jacks. Jumping jacks. So in the homework, they ask you to do that, and they said to use their website, but you don't have to. Their website is no longer working because it's an old textbook, so you can use desmos.com. Okay, just one more. So just X them out to get rid of the old ones, and another one that we did was y equals 2 times 3. And then there's this button that says a to the b. So that will raise it to the x power. And then there's that exponential function that we graphed earlier.